Hello everyone, welcome to our lecture number 6 of Fluid Mechanics and Hydraulic Machines subject. Today we are going to start our new topic, that is the hydrostatic law, and we'll see about the different types of pressures. Okay, so if we talk about our previous lecture, means lecture number 5th, we had covered the Pascal's law. So let's start our today's lecture, that is based on hydrostatic law. So let's discuss what is hydrostatic law. Hydrostatic law which state out that the rate of increase of pressure, in a vertically downward direction means if I have one container, one closed container which are having full of liquid at a rest position. So there is a pressure difference. There is a pressure difference in a vertically direction, in vertically downward or upward direction. So there is a change in a pressure from this top or the free surface of this liquid to the bottom surface of the liquid due to the difference of height. Okay, suppose let's say this height difference, due to the difference of height we have a different pressure head value at this point, a lower level, and also at this upper level. So sorry, hydrostatic law is stated the rate of increase of pressure, the rate of increases of pressure when you are going downward direction, the rate of increase of pressure in vertically downward direction must be equal to the specific weight, or it is a weight density, must be equal to the specific weight of a fluid at that point. So the weight density is differed when you are going the vertically downward direction in any fluid when that fluid is at a rest condition. Okay, so simply in today's lecture we will prove about the rate of increase of pressure in a vertically downward direction. That means rate of increase of pressure in vertically downward direction, that is your Z direction, that is equals to the specific weight or the weight density. This will we are going to start proving this formula. So you can see that in this figure, in this diagram, there is a static fluid or a fluid at a rest position which are having one arbitrary element which is ABCD, and the cross sectional area of this element from this, like we are viewing from this top side, then the cross sectional area of this element at this section which is a delta A. So the delta A, that is the cross sectional area of element, and the delta Z which is the height of fluid, this is your delta Z which is the height of fluid from this B to C. Okay, there is a pressure which is acting on a side AB, because we are going to find a pressure difference in a vertical direction. So that let's consider a pressure which is applied on a side AB which is acting at a distance of Z. This one is, you can see that this one is a distance of Z from the free surface of liquid. The pressure P which is applied on a side AB, and the side AB that is at a distance of Z from this free surface of liquid. So P, that is the pressure on a side AB, and the Z which is the distance of fluid element from the free surface. So these all are the simple nomenclature of this fluid element. So let's start our derivation. So basically we are going to find the first and the foremost different pressure forces which are applied on this fluid element. So let's start different forces. The first force, just remember that we are going to find the forces in only in vertical direction. Okay, so first pressure force, the force on a side AB, that is force equals to pressure into area. We are going to find the force on a side this AB, on a side this AB. So as we know that the force that equals to pressure into area, and we know that the cross-sectional area of this element, which is delta A, so that we can write that P into delta A, which is acting perpendicularly to the face AB in your direction, in your downward direction. Okay, so the second force that will be acting also in upward direction, which is the force due to the difference of or the height of the element. So second force, that is force on a side CD. So let's see the force. This one is your force which is acting on a side CD, that is your upward direction force. So this force which is applied on a side CD, that is the again pressure P plus del P upon del Z into del Z into delta A. This one is your pressure force or the pressure. This one is your pressure. Okay, as per your mathematical chain rule, this one is a change in a pressure due to this delta Z. We can say that this P, that is your original pressure, and del P upon del Z into delta Z, that is the change in a pressure due to delta Z height into area. So this one is your pressure into area. So your force that equals to pressure into area, which is applied on a face CD in a vertically upward direction. So let's say the vertically upward direction, that is the positive or negative. You can see that the two forces which are applied in opposite direction. So firstly we have to take one which is positive, and second force that will be a negative force. Now considering the third force in a vertical direction, that is the weight of this element. Okay, force number one, that is Px delta A. Force number two, that is P plus del P upon del Z into delta Z into delta A, that is the change in pressure due to the height delta Z into delta A as per our chain rule. Okay, and the weight of element, that is the third force. So weight that equals to mass into gravitational force, and the mass that equals to, we can write that the rho into V into G. Mass is replaced by rho V. Rho, that is the density of that fluid, and the V, which is the volume of fluid. So rho into G into the volume, this V which is the volume. So what will be the volume? So we can see that the cross-sectional area is delta Z, and the height is cross-sectional area is delta A, and the height is delta Z. So the volume is area into height. So we can write that the area into height, that is your volume. Okay, that will be in mm cube or meter cube. So there are three forces which is applied on that arbitrary fluid. One force which is the downward direction, which is applied on AB face. Second fluid that is applied on a face CD, which is your upward direction force, and the third force, that is again the weight of fluid due to its gravitational force. Okay, so as we already assumed that the fluid which is at a rest position, so the forces which are applied on a side BC and AD, that means BC and AD, on this side BC and on this side AD, that is must be in equilibrium. Okay, so that we can conclude that this element is at a rest position. This element is not moving in your x direction or in horizontal direction, so that we can write that this force which is applied on AD and the force which is applied on a BC, that is in equilibrium condition. Okay, so now let's take resolving these forces in horizontal or in vertical direction. So if you are going to start resolve the forces in a vertical direction, the first force that is applied on a AB, which is P into delta A. Okay, so this one is, if you are going to take this one is downward force is as a positive force, then your upward force which is applied on a CD side, that is negative one. Okay, if your downward direction force that is of the positive, then your upward direction force, that will be your negative force. So this one is your upward force, that is this one P plus del P upon del Z into delta Z into delta A, which is your upward force. P, that is our original pressure, del P upon del Z into delta Z, that is the change in a pressure due to the height delta z. Okay, and our third force, that is on weight of element, which is rho g delta a delta z, rho g delta a delta z. This one is our third force, which is again going to the downward direction. So this one is again the positive force, that will be equals to 0. So there is a three forces which is applied on a fluid element. So now let's simplify this equation. Let's opening this bracket and multiply this delta I with this. So we can write that this P delta I as it is, and this P which is multiplied with delta I, so that it was again the P delta I, this del P upon del Z into delta Z into delta I. So we can write this, and this whole term is the same as it is. Okay, so in this equation, this minus P delta and plus P delta I will be cancelled out, and remaining term, so the simplified this equation, the minus del P upon del Z into delta I, that is as it is, plus rho G delta A delta Z. Okay, so again we can write that this negative term that will be goes to the right side, and it will be your positive term, this one. And in this term we can cancel out this delta Z delta A and delta Z delta A. So remainings are, so after the cancellation of this delta Z and delta A, also all this side delta Z and delta A, only the remaining term, that is your del P upon del Z, that equals to rho into G. Okay, so this rho into G, that is our specific weight or your weight density. Okay, so we had proved that this del P upon del Z, that equals to rho into G. So that is the change in a pressure in vertically downward direction, that is your delta Z direction, that is equals to your specific weight, which is your hydrostatic law. So in your hydrostatic law, which states the rate of increase of pressure in a vertical direction is equal to the weight density of fluid at that point, and this one is your hydrostatic law. So the many times in your examination they ask what is hydrostatic law, or they can ask in this term like a pressure variation in a fluid at a rest position. So these two terms are same. Okay, so in this term, again, by integrating the above equation, means this equation, when your delta Z, this del Z, it goes to this right side, and we are going to integrate this term, that is dP, that equals to rho G dZ. So only here, that is P, and this dZ, that will be your Z. So this one is your P equals to rho G Z. In many books there is a H in replace of Z. You can see in your many books there is a different nomenclature for this Z. Z, that is your head in meter. Z, which is your head. As we had already discussed, that the Z is your pressure head, that is the pressure which is acting on this AB side, means the distance from this particle to the free surface, that is your Z, and the unit of Z, that is H. So in the many book there is a rho G H, or in this book you can see that there is the rho G Z. So in this above equation, Z is called the pressure head. Okay, so pressure head H or Z, that equals to P divided by rho G, that is in meter. Okay, so this was all about hydrostatic law, and our next topic, that is the different types of pressures. So you have to remember this diagram. How to remember this? Let's see that the diagram. So firstly you have to draw one line. This one is your P absolute line. I'm writing over this P suffix AB, that is your P absolute line. This one is your vertical pressure line, means in this direction there is a pressure P. Okay, this one is your P absolute line, means this one is your zero vacuum pressure, and as we are living in the atmospheric pressure, so this line is called PATM. ATM, that is P atmospheric pressure, P suffix atm. So this one is your P atmospheric pressure line. And next step, you have to mark 2 points, a first point that is the point A, and the second point which is point B. So simply, if you are going to find a pressure with the reference to this, with respect to this P absolute line, means if you are going to find this pressure with reference to this P absolute line, then this pressure at a point B is called the absolute pressure. Likewise, if you are going to find the value of this pressure with respect to this pressure absolute line, at that time this pressure A is called absolute pressure. Okay, so this one is your absolute pressure. And whenever you are going to find the pressure by taking the reference of this P atmospheric line, above this pressure, that is your gauge pressure. I mean to say like this, I am going to find this pressure with reference to this P atmospheric. So this pressure is called positive gauge pressure, because you are going to take, or you are taking this reference point as a P atmospheric as a reference point. And if you are going to find this pressure point B like this by taking the reference of this P atmospheric, then this one is your negative gauge pressure, means vacuum pressure. Negative gauge pressure, that is your vacuum pressure. Positive pressure, that is your gauge pressure with respect to this P atmospheric. But whenever you are going to find the pressure with respect to this absolute line, then at that time all the pressures are called absolute pressure. So as this definition shows that the absolute pressure, which is first definition, it is defined as the pressure, it is defined as the pressure which is measured with reference to absolute vacuum pressure. Means whenever you are going to find the pressure value by this absolute vacuum pressure, at that time this pressure is called absolute pressure. Again, this one is your absolute pressure, because you are going to find your pressure by taking the reference of this P absolute over here, and over here that is again the P absolute. Second definition, that is the gauge pressure. It is defined as the pressure which is measured with the help of pressure measuring instrument. Whenever you are going to find the pressure with your U-tube manometer, with the differential U-tube manometer, so these all are the different types of pressure measuring instruments. So in which the atmospheric pressure is taken as a datum. So in a gauge pressure, atmospheric pressure is taken as a datum or as a reference pressure. But in absolute pressure, there is a zero vacuum line, or P absolute pressure is taken as a reference pressure. Okay, so the atmospheric pressure on the scale is marked as a 0. In this gauge pressure, the atmospheric pressure is 0, and in absolute pressure, this absolute pressure line, it will be your 0 line. So vacuum pressure, it is defined as the pressure below the atmospheric pressure. Yes, this one is your atmospheric pressure, and below this pressure, by taking the reference to this atmospheric line, this pressure is called the gauge pressure or the negative pressure. Okay, by taking this atmospheric pressure as a reference line, and you are going to find the positive pressure from this line, at that time this pressure is called positive gauge pressure. Okay, I hope you are understanding these different types of pressures. Only you have to remember two reference lines. First one is absolute pressure lines, and second line above absolute pressure line, that is your simple atmospheric pressure line where we are living. Okay, so above atmospheric pressure, that is gauge pressure or positive gauge pressure. Below atmospheric pressure, which is negative gauge pressure or vacuum pressure. But the below atmospheric pressure line, which is your absolute pressure line, okay, that is zero vacuum absolute pressure line. That means this line is your absolute vacuum, and which is a zero vacuum line. So whenever you are going to take as a reference this line, and you are going to find the pressure, then that type of pressure is called absolute pressure. So the absolute pressure is atmospheric pressure plus gauge pressure. For this point, this absolute pressure is this atmospheric pressure plus this gauge pressure. Okay, so absolute pressure is the summation of atmospheric pressure, means this much, up to this, and gauge pressure up to this. And the vacuum pressure, that is atmospheric pressure minus absolute, means this atmospheric pressure minus this vacuum, you are negative of this vacuum, then you have this P vacuum pressure. Okay, so thank you. This was all about today's lecture. So in your task, you have to write this derivation about the hydrostatic law and the pressure variation at a fluid rest, this whole derivation. After this derivation, your second question, that will be your different types of pressure. Okay, write this all and submit us on the Google Classroom. Thank you.